Pause. Why am I starting these right away just like this, without even thinking twice? It's like e to the x and ln, right? Derivative of e to the x is e to the x. Derivative of 2 to the x is 2 to the x. No big dealio. Now, we have some extra stuff to remember. Derivative of e to the u is e to the u. Derivative of 2 to the u is 2 to the u. We have some extra stuff to remember. Derivative of ln of u is 1 over u times u prime. 1 over u times, okay, we have some extra stuff to remember. The derivative of ln of u is 1 over u. Okay, it shouldn't be rocket science how to start it, right? Now, do these guys have division, yes or no? No. Okay, so sweet. It's just going to be limb times u prime, well, derivative of x is 1, times limb times u prime, right? This is already 1 over, because it's an ln. Well, it's a logarithm. 1 over, what do I need? ln of, put the limb down here, because you have division. But what do you still need, because it's a u prime? Negative sine of x, right? This is not working well. What does this guy need? I need a limb, right? Just keep it in the denominator with everything else. And then I need a... yeah, sure. There you go. But do you guys get the idea? They're not meant to be super hard. As long as you have e to the u and ln of u down, you should at least know, okay, keep it the 2 to the u, limb, and then u prime, right? 2 to the u, limb, and then u prime. As soon as I have any sort of logarithm, oh well, think ln. 1 over u, limb, keep it down there, u prime. 1 over u, limb, u prime. It's all about get the limb in there. ln of b, or ln of a, or ln of whoever the base is. I don't really care. Do you guys go quotient ruling? Bottom, d top, minus top, d bottom, all over bottom squared. Did you guys simplify the complex fraction? Why not? 2, you just wrote it all disgusting and gross? Yes. Oh my gosh, I've trained you too well. So then it cancels out, and you just have x plus 5. This one just becomes a 2x. You just scare me if you ever get to a multiple choice like this, that you're just like, nah, it's not worth it. Because look, it's not that bad, right? Once you get into Lagrange error bound, say it's not worth it. Just kidding, you want to get that right. Well, second semester, the hardest thing, ask Georgie. Lagrange. Lagrange. It's like L'Hopital's, but not at all. Okay. So what do we have? I think we have a x plus 5 chilling up top. I think we have a square root of x with an ln of 3 down bottom. And then I think we have a negative x plus 5 all over a 2 root x. And I think that's going to reduce with that. And then I think... Wait, I did not write that right. Sometimes the best things take a little time. It's okay. Oof at me too. 2x ln of 3. Dun 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 dun. Dun dun. All right, I'll box the rest of these. These are okay. They just could be rewritten maybe in a different order. How do we do? Kathy's just laughing. Not sure if that's good or bad. Do you guys want to hear the new Share the Hope submissions that might challenge you to make some of your own? People can't just open up to page 207 of your life and expect to understand your whole story. I don't know where the hope is in that, but that's okay. And it's from Aaron Egyptoraptor Hansen. I don't know who it is. Do well. How hard can it be? Look up in inspiration, down in desperation. Never side to side for information. Cheaters go to... I think Mrs. Ranieri, isn't that her quote, would say USC. This person left 4 blanks, I'm guessing UCLA, or they were alluding to something that we shouldn't say. All right, so. Technically, cheaters can go to heaven, saved by grace. Okay, so. This is section what, 4.4? So why didn't we end this on Friday? Well, number one, I don't think we could have done that in 2 minutes. And number two, there was still one more topic that we need to talk about. And super random, that one more topic happened to be on a Moore Park College first exam for Calculus 2, but in a much harder form. Had to do with logarithmic differentiation. Wasn't stated in the problem, but was the only way to go. Super random, but I was tutoring an alumni last night. Okay. She was like, logarithmic differentiation. Yeah. Because Calc 1 in college almost never involves transcendental functions, meaning no e's, no logs, no inverse trig. And it comes later. And it comes later. It comes in Calc 2. But then when it comes hard. I know. Not bad. These aren't even the day old ones. I could have gotten the 50% ones, but I was being good. Didn't want to shortchange. Oh, it's the next day. It said September 24th. Oh, the day that it's like it should be sold by. Who's the Spartan final? It might have been 30% off. But yeah, there was a whole cart. I bet it's all gone by the time you normally get there, though. Because there was only a few things on this morning. Okay, you guys definitely want paper towels, though. This is a mess. You'll survive. Ooh, I like the powder one. All right, if you want one, go get one. Hold on, pause. Someone take paper towels. Shoop, 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 shoop. Got it. There's plenty of pieces. Because they wanted brownies and fruit and muffins and donuts. I just didn't go to the donut store. I couldn't get it all in one place. So I just went to Smart and Final. Okay. If you start choking and need water, just rush out to the water fountain. Okay. Thank you, those of you that helped me. If you decide you want to help some more at any point in time during class, go help some more. I don't need it. I'll probably steal a brownie later, and I stole a muffin this morning. Oh dear. And my workout videos didn't work this weekend. So sad. All right. What is the only way to derive this function? Bring down the x and subtract a 1, of course. Nope, but the answer is going to be there waiting in the multiple choice. What's the only way? Take the ln of both sides. What happens to the power when you have an ln? Mm-hmm. The only way to derive this is using implicit differentiation after putting in a logarithm. Now, it doesn't mean that's the only time it's useful. Logarithmic differentiation, putting in an ln, can be useful even when you don't have a f to a g or a u to a v. But if you have variables to variables, you can't use the power rule because there's no constant in the power. You can't use an exponential rule because there's no constant in the base. The only way is to break it up, and the only way to break it up is with a log. And the only log we want to use is an ln. Aryan.
I was just wondering, there's a question like this on the homework. So there's x to the pi. So for that, would you use power rule or do you have to use
Why?
power rule? But then I was like,
Why?
2.1.
Pi is a constant, totally legal. But were they trying to trick you?
Yes. But then what do you just like pi minus 1 or can you like approximate 2.1?
Pi minus 1. So what's the derivative of ln of y? How do I take a derivative of x times ln of x? The other p rule, right? Product rule. Second? D first, plus? So can I say dy dx is equal to ln of x plus 1 times x to the x? Oh, well, I multiplied y to the other side because he can't stick around for my derivative. And when I multiplied him to the other side, I said, oh, by the way, I know who you are. Dun, 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 dun. We did last year. Not so much the actual AP, but on our exams at least. So can anyone, you guys ready? My ones that are sometimes bored in class? Can anyone make for me, because I always make for you, make for me an example where logarithmic differentiation would be helpful, but not required? Ponder. Don't give me the answer quite yet. People are still writing. I need a new page first. Can anyone make for me an example where logarithmic differentiation might be helpful, but not required? Aryan, go. Oh, okay. We'll get back to that one in a second, though. Want to make one from scratch? Yeah. You raised your hand. Someone else want to take it? Go for it. Can you give me an equation as to what you're thinking?
Sure. Y equals negative 5 times e to the 3x plus 2.
You would need ln if you were trying to solve for x given y. I think you're thinking exponential growth where you need ln to cancel out the e. Is that what you're thinking? Ah, that's necessary. No, but it's good. Like pre-cal, ln's are needed in order to get to powers. So if the x was the unknown that you were trying to solve for, Maggie's absolutely right. You would need ln to get there. But what would be a derivative problem? A function whose derivative that we're trying to find where an ln would be useful but not required. Aryan. Can you give me one?
Like y equals big parentheses, like x minus 2 cubed over x plus, and then all to like the 1/2, like the whole thing.
Like my something? What do you mean, ew? You know how to do that. It'd be bring down the 1/2, make it a negative 1/2 times u prime, and u prime would be a quotient rule with a chain rule. So how is ln useful but not required? Not Aryan, because he's thinking of a problem in homework that he's already tackled. Someone else. How is ln useful but not required? Why take ln?
Oh, because you can do the, like for, you get a y, and you solve for dy dx, and you have a y, and the other side.
But how is it useful on this side? Because isn't that what you're trying to make easier? You're right. You are going to have 1 over y dy dx and move it and then plug in. That's all good. But how does it make this easier? But not yet. What's the first thing that we'd have to do before the subtraction property? Yeah, buddy. We can bring down the 1/2. No deriving here. We're just rewriting, right? We can bring down the 1/2. Then we can make it. Why am I going to say 3 ln of x minus 2 minus ln of x plus 4? What'd I do? Bring down the 3. Minus for division. Now what can we do? What Riley already said, which is the 1 over y dy dx. What happens over here? It's a lot more fun than it used to be. What's the derivative of ln of u? 1 over u times? Minus 1/2 Do it again. 1 over u times u prime. Look at Aryan making it easy, no crazy u primes. Then we end up with, not easy, it was a good example. Why am I going to do a blank with a big old parenthesis? Yeah, I'm going to plug in. Dun, 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 dun. Multiply the y by the other side and plugged it in. Yeah.
Let's say it's ln. Okay, let's say ln x is in is being squared.
Ooh.
You can't do the power.
It's a great question, though. Why is this not as easy as it looks, even though it's not impossible? Bring down the 2. What's the ln property from pre-calc? Ln of a to the b. Even though you don't always see the parentheses, the power has to be in the argument alone in order to move in front. This one was the only way to derive that one. Uh-huh. Chain rule would say. Mm-hmm. Dun, 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 dun. And can I bring that 2 up to be an x squared? Mm-mm. Or can I? Now that the 2 is just a coefficient of an ln, I actually can not randomly put in an ln. Any number in front of an ln can always be rewritten to power, but a whole ln raised to a power cannot be brought down. Weird, huh? And the only reason this came down was because I was taking the derivative, not because of pre-calc. Okay. So, whether you have an ln of a really nasty expression, use your log properties to simplify. Or you have a really nasty expression and the directions say something about logarithmic differentiation, put in ln's to simplify first. Or whether you have a problem that would be impossible, would be impossible to solve without ln's. ln's either can be, well, I'll just say can be, quite useful. So kiddos, let's see if right here at the very end of homework, you cannot be tricked. Ready, set, and go. No discussion, you, yourself, and you. Can you avoid the tricks? Derivative of a. Oh, did you get 0 though? What's 2.718 to 8 to the power of 2.718 to 8? A number that you derive, which is always 0. Ooh. Wait, shouldn't you have known that? E to the u times u prime and the derivative of e is 0, just like the derivative of pi is 0, just like the derivative of Avogadro's number is 0? Making up stuff. But there you go. Struggle. How about derivative of b? How about the derivative of c? E is just a constant. Bring them down, -1. Don't approximate. Because it's not a to the u. It's not a to the u. But letter D? Yep.
Oh shoot, I forgot the y again.
No!
I did it.
Uh-oh, I need to derive that.
I literally.
Yesterday, at Starbucks,
No.
Aryan. I was like, Aryan, what happened? He's like, oh, I just didn't want to do it.
Well, now it was unintentional.
I don't know about that.
Guess what? You could memorize that as another derivative rule if you really, really want, or you could just know to always put an ln. I don't know what's safer for your brain, because if some of you are going to forget every time what to do, maybe you should just memorize them. But the problem is, what if they change one little thingamabob and you don't know the process? I don't like memorizing if you can avoid it. Some things, obviously, I make you memorize forevers, and, well, the evers fell down over the weekend. But anyway, yeah, go team. It's not the greatest wall to hang things on. Does it make sense, kiddos? But can some of you still get tricked? Yes, so watch out. Back of your spirals, on your marks. Get set, and whoo, go. Yeah, I have the book up. Let me go ahead and, which one are you asking about? Okay. Take it away, cool kids. Is it e to the t sine t for number 4? Okay. When does cosine equal 0? Pi over 2 and 3 pi over 2? Oh, it's where a equals 0. Oh, not where t equals 0. Whew, you might have a picture on the way out the door so that way you can see if your answers line up with mine. I just finished the last one. Oh, I missed it. I'll move it in just a second. What page was... Oh, I was so ready for it. Oh, well. Number 31 was the one that Aryan was asking about. Yeah, I'm just going to peek at it. Can you see everything? Yeah, I think so. There are other ways to get 0 on the last one, like if t equals whatchamacallit, pi over 2 and pi over 2, but they just ask for a, so you only have to worry about a. There's a gas pump. Number 31. That the line with a slope m passes through the origin and is tangent. Y equals ln of 2x. You can use the origin as a point. You could have your 1 over a. 2a. You guys can go if you're ready. What is the value of m? Tangent. Cancel. I didn't do the derivative in my head. Bye, guys. A line that passes through the origin. Bye. There you go. This is it.